The direction of the electric current is the direction the charges move. They go from plus to minus. The size of the current is determined by how many charges flow through the cross-section of wire per second. When one column of charges flow through, the current is 1 ampere. Coulomb is the unit for the amount of electric charges. When one column of charges flow through here per second, the current is 1 ampere. Look at the circuit below. When the wire branches out, the charges divide and flow in parallel. The 6 column charges are flowing from left side. 4 columns of them went through the top path and 2 columns through the bottom. The charges don't get lost. They come back together when the path merges again. Just like 1 dozen of pencils are made of 12 pencils, 1 column of electric charges are made of 6.24 times 10 to the 18th power electrons. This is called Kirchhoff's first law, current law. An ammeter is used to count the number of charges. Just place the ammeter in the middle of the path to count how many charges flow through. The unit is in amperes, which is the number of charges flowing through per second. It's true that placing the ammeter in the middle of the path can measure the number of charges passing by, but wouldn't there be resistance in the ammeter that would slow down the flow of the charges? You're right, Karen. That's why the resistance of ammeters are made as small as possible. As we saw, if 1 column of charges flow through per second, then the current is 1 ampere. Hence, if Q columns of charges flow through per T seconds, the current I ampere would be the size I equals Q over T. The units would be ampere equals coulomb over second. The current is the momentum of electricity flowing during a certain period of time. It answers how much electricity is flowing at this moment. Meanwhile, energy represents the total amount of electric flow during a certain period of time. Therefore, even if the current, the momentum of the flow remains the same, when you run the circuit for 2 hours, the energy will be twice as large. To calculate energy from current, you use energy, coulomb, equals current, amperes, times time, seconds. For example, 3 amperes of current run for 5 seconds would yield the amount of electric energy. 3 times 5 equals 15 coulombs.